Hello everyone. In this video, I am comparing various parameters of common base, common emitter and common collector configurations. Yes, if you see the first one, it is the circuit diagram. Yes, and the common base configuration, yes, base is common to both input and output. And here the input is emitter and output is collector. And in the common emitter, emitter is common to both input and output. Base is input terminal and collector is output terminal. In common collector configuration, collector is common or grounded. Base is input and emitter is output. Okay. And these are the terminals. So here the input current is IE and here the input current is IB, and in the common collector the input current is IB. Let me write the range. IA is in milliamperes. IB is in microamperes. Okay. And then the output current is IC. See here IC. And here also the output current is IC. Here the output current is IE. Okay. So all are milliamperes. Another important point is the current direction. See, as this is NPN transistor, see the emitter current direction is like this. So as the emitter current is outside from the transistor, you must include the collector and base currents inside. Okay. Then the input voltage is the voltage between the input terminal and the common terminals. So the voltage between these two is VEB, and here the voltage between these two is VBE, and here the voltage between these two is VBC. Then output voltage is the voltage between the output terminal and the grounded terminal. So here it is VCB, yes VCB, here it is VCE, here it is VEC, okay VEC. And the next parameter is current amplification factor. The current amplification factor is defined as output current by input current, okay. In the case of common base configuration, output current is IC and input current is IE, and the current amplification factor is denoted by alpha. So alpha is equal to IC by IE. As IC and IE are approximately same, the range is between 0.95 to 0.99. And here the current amplification factor is beta. Beta is IC by IB. Yes, IB is very less, so the beta range is from 50 to 500. And the next is gamma. Gamma is IE by IB. As IE is more than IC, here gamma is more than beta and the range is 51 to 501. So here gamma equal to 1 plus beta. Next parameter is input resistance. Input resistance is very low. The reason is, in the common base configuration, what are the input terminals? Emitter and base. In the common base configuration, what is the input terminal? Emitter, and the grounded terminal is base. So the input that you have to apply is between emitter and base. As the emitter is always forward biased, the current is maximum, so the resistance is very less. And next, if you go for common emitter, here the base is input terminal. So compared to this, it is having less doping. So that is the reason input resistance is somewhat high, very little bit high than common base. So it is, therefore the input resistance is low. Here is very low and here is low. And now if you see the common collector configuration, the input terminals are base and collector. You know the collector base junction is always reverse biased. So that is the reason the input resistance is very high. Then the next parameter is output resistance. Is why the output resistance is very high in common base. If you observe the circuit, yes, the output is at collector and the grounded terminal is base. So you have to take output at collector at common base. Collector is always reverse bias. So at reverse bias, you are going to have less current. So that is the reason you have high resistance. Very high. It is very high. And in the common emitter, yes, the output is at collector and ground is emitter. So emitter is somewhat forward biased. So that is the reason is between these two terminals, the output resistance is high, but it is less than very high. Is here is the common collector. For the common collector, the output terminal is emitter. So obviously emitter is always forward biased. So that is the reason its output impedance is low. And then coming to the current gain. Yes, here is the current gain. I can say current gain and the current amplification factor is same here. So it is less than 1. Yes, it is high and it is very high because it is here it is 50 to 500. It is 51 to 501. So it is greater than common emitter configuration. And the voltage gain is moderate for common base. The high voltage gain is for common emitter, and for the common collector the voltage gain is less than 1. And the phase shift between input and output. For the common base there is no phase change, and for the common emitter you are going to get 180 degrees phase between the input and output. For the common collector there is no phase change between the input and output. And these are the input characteristics I already explained. Here the input characteristics are IE versus VEB when VCB is constant. Here the curve shift to the left. Here IB versus VBE when VC is constant. Here the curve shift to the right. And this is IB versus VBC when VEC is constant. IB decreases with the increase in VEC. These are the output characteristics for common base. IC versus VCB when IE is constant. See here, these are the output characteristics, and see this is 0 and this is the saturation region concept. Here IC versus VCE when IB is constant, and here IE versus VEC when IB is constant. As common emitter and common collector configuration output terminals are somewhat similar, the output characteristics are very similar. Okay, so this is about the comparison of the three configurations: common base, common emitter, common collector. I explained the input and output characteristics of all these configurations in very detail in the previous videos. Please go through those videos for detailed explanation. And when you're going for exams, you must remember this table. Okay, thank you very much.
Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.